All right, so today we are going to do some new material. This is chapter 3.4. So we are introducing our last form for graphing. So before we had slope-intercept form and point-slope form, so this is standard form. So standard form is in the form ax plus by equals c, where a, b, and c, those are just real numbers, and a and b are not both 0, so they can't both be 0. So standard form tells us a couple things. It tells us when we have horizontal lines, vertical lines, or it can also tell us easily what our x-intercept is and what our y-intercept is. And so we're actually going to use our x-intercept and our y-intercept to graph. So let's start with horizontal lines though. So the graph of y equals b is a horizontal line. The line passes through the point 0, b. So whenever you have y is equal to a number, that's a horizontal line. And then vertical lines, similarly, the graph of x equals a is a vertical line, and the line passes through the point a, 0. So whenever you have x equals a number, that's when you have a vertical line. So the x-intercept of a graph, this is the x-coordinate of a point where the graph crosses the x-axis. So anytime that a function crosses the x-axis, that is your x-intercept. It occurs when y equals 0. So if you want to find your x-intercept, you're going to substitute in 0 for y, and then you'll solve for x. For a y-intercept, this is the y-coordinate of a point, and this is where the graph crosses the y-axis, and it occurs when x equals 0. And then if you were to want to find the y-intercept, you would plug in 0 for x and solve for y. So let's do some practice problems. So if I wanted to graph y equals 4, and for part B, x equals -2, I'm going to get either a horizontal line or a vertical line. So for A, if I were to graph y equals 4, my graph would look like this. So for this graph, I would just go up to the point 4 along the y-axis, and then I would draw a horizontal line, because what I'm looking for is every single point where y is equal to 4. So my x values can be changing here, but y always has to be 4. So we're looking for every single point on the graph where y is equal to 4. So you are going to have a horizontal line. So it's a little bit backwards from what you might think. If it's y equals 4, it's horizontal. And then if you have x equals -2, we should get a vertical line. So if we were to graph x equals -2, go to -2 on your graph, and it will look something like this. So we want every single point where x is going to be equal to -2. And here our y values can be changing, but our x values always have to be -2. So at any point on that graph, x is going to be -2. All right. Okay, so now we want to use intercepts in order to graph linear equations. So for the first one, we're given the equation 3x plus 4y equals 12. And so in order to find our intercepts, we want to plug in a 0 in for x to solve for y, and then vice versa. So let's start with a table. So first, I'm going to plug in a 0 in for x. So in place of a 0, or in place of an x, I'm going to substitute in a 0, and I'm going to simplify that. So I should get 3 times 0 plus 4y equals 12. So that will give me 0 plus 4y equals 12. And then if I divide by 4 on both sides, I will get y equals 3. So then in my t-table, for x, my input was 0. So I substituted in a 0. So I inputted in a 0 for x. And then for y, I will get y equals 3. So then on my graph now, I'm going to go ahead and plot that point. That's a point 0, 3. So I'm going to plot that point there. That's 0, 3. For the next one, instead of plugging in a 0 for x, I'm going to plug in a 0 for y. When I do that, I get 3x plus 4 times 0 equals 12. Remember, whenever we have something that looks like 4y, that's really 4 times y. So when we substitute in a 0, it's 4 times 0. So then if we were to simplify this further, we'd get 3x plus 0 equals 12. And then if we divide by 3 on both sides, we get x equals 4. So now in our t-table, we substituted in a 0 for y, and for our x, we got 4. So then now on our graph, we're going to plot that point 4, 0, which should be there. And now we're just going to connect those 2 points, and that is our function. So we just find the intercepts and connect them, and that's our graph. Okay, go ahead and try the next one on your own. I will give you the t-table and a little bit of a hint to get you started. We want to plug in 0 for x first and solve for y. So go ahead and pause the video and see if you can find your y coordinate when x is 0. All right, so hopefully you pause the video and you simplified this expression to be 0 plus 3y equals 24. And then if you divide it by 3 on both sides, you should get y equals 8. And then hopefully you put this in your t-table. So your x value was 0, your y value is 8, and then you graph that point on your graph. I know that this graph that I have is a little bit small, so I just kind of estimated that point a little bit. And now we are ready to find our x-intercept. So now to find our x-intercept, we want to plug in 0 for y. So in a different color, I have negative 12x plus 3 times 0 equals 24. And go ahead and solve for x again here and pause the video. Okay, so hopefully you pause the video and this is what the rest of your work should look like. So you have negative 12x plus 0 equals 24, which can be simplified down to negative 12x equals 24. And then if you divide by negative 12 on both sides, you should get x equals negative 2. So then in your table, you substituted in a 0 for y, and your x was negative 2. So now on your graph, go ahead and graph that point negative 2, 0, which should be right there. Connect your 2 points. And remember, anytime we're drawing a line through our 2 points, we always put the arrows on the end because our function doesn't end there. Our graph doesn't end there. It just keeps on going, so the arrows on the end are necessary each time, so please don't forget them.